Hello everyone, I am Dr. Himamaheswara Rao, Assistant Professor of Physics, Department of Freshman Engineering, Institute of Aeronautical Engineering, Hyderabad, Dundigal, Hyderabad. Today we are going to discuss Bohr's atomic model. In the previous lecture we discussed about line spectrum, Bohr empirical relation, Rydberg relation, and today in this lecture we are going to discuss J.J. Thomson plum pudding model, Rutherford planetary model, Bohr's theory of atomic model, and then references. In previous lecture we discussed the line spectrum, which is due to the emission of radiation in different wavelengths that is observed by different scientists at different regions. For example, whenever hydrogen gas, monoatomic gas of hydrogen is exposed to higher temperatures, it emits radiation, particularly in visible region at 6563 angstrom, 6861 angstrom, 4341 angstrom, 4102 angstrom, 364 angstrom, and meanwhile there are several lines from 4102 to 3646 angstrom. For these, the scientist Bohr gave an empirical relation. They are following some particular regular manner, so he gave some particular relation given by in terms of wavelength, lambda equal to 3646 into n square by n square minus 4, where n is equal to 3, 4, 5, etc. All the lines are following this particular formula, which is given by Bohr. Later, some other scientists found that these lines are not only in the visible region, there are lines in the IR and UV region also, which are found by scientist Lyman, Paschen, Brackett, and Fund. And those lines are also following particular order of fashion, and those series are also called by those scientists. Later, scientist Rydberg gave one more relation in terms of wave number, which is the inverse of wavelength in vacuum. This wavelength is in vacuum, that is called wave number. So wave number relation, that is equal to RH into 1 by n1 square minus 1 by n2 square, where RH is the Rydberg constant and is given by 1.096777576 into 10 power 5 per centimeter. Here n1 and n2, in the case of n1 and n2 must be greater than n1. That means n1 is the lower number, n2 is the higher number. So not only Bohr series, all the series are following this particular formula. But there is no proper relation or proper investigation, proper discussion was not given by these scientists for the line spectrum. There is no proper discussion of line spectrum, why the lines are forming at that particular wavelengths. But later, these are the lines given by Bohr series and Lyman series, and these are the lines at Paschen series. All are following the Rydberg formula. This diagram also shows the lines, different lines in Lyman, Bohr, Paschen, Brackett, and Fund series. Later, J.J. Thomson, he also gave one atomic model to discuss about the atom, structure of atom. So according to this model, All positive charges are distributed throughout the atom, and negative charges are also among these positive charges. For the first time, J.J. Thomson discovered electron in 1897. After that, in 1904, he proposed the plum pudding model. This model is also called watermelon model. So, according to this model, positive and negative charges cancel each other, and resulting in an neutral state of the atom. This model also suggests that the mass of atom is uniformly distributed throughout, not only concentrated at particular point. Total mass of the atom is distributed throughout the atom, and the atom has radius about 10 power minus 10 meters. Okay, so but later again Rutherford gave planetary model. According to this particular model, atom structure of atom is like similar to planets revolving around the sun. As planets are revolving around the sun, in the same way, electrons are also revolve around the nucleus, where nucleus contains the protons, positive charge of the atom. According to this model, entire positive charge is concentrated only at center of the atom, and it is very small. It occupies very small space, and electrons are distributed throughout the atom. Most of the space of atom occupied by electrons, and these electrons revolve around the nucleus. These negative charged electrons are revolve around the nucleus, but according to this model, as electron is moving in the orbits, means as the charge is moving, according to Maxwell, it must emit radiation. As the electron is moving around the nucleus, for example, this is the positive charge. Electron is moving inside the outside the nucleus at some particular distance in some particular orbit. If the electron is moving, it must emit radiation according to Maxwell's electromagnetic theory. If the electron is emitting radiation, it must come closer to nucleus, and after some time it must fall down into the nucleus, as it is emitting radiation. After losing its energy, it must fall down to the nucleus. That means there must be no existence of atom after some time. So this model could not explain this type of phenomena, why the electrons are revolving only in the particular orbits. These models, J.J. Thomson and Rutherford planetary model, could not explain the line spectrum, why those particular lines are emitted by gases, monoatomic gases, when they are exposed to higher temperatures. But this particular model tells that entire mass is concentrated only at the center of the atom, and it is very small, and electrons revolve around the nucleus at certain distance. There may be several orbits also, according to this model. Okay, so later Niels Bohr in 1913 explained the origin of line spectra on the basis of two central ideas. One is the concept of photon, and the other one is the concept of energy levels of atoms. Bohr combined these two concepts nicely to explain how light is emitted and why the spectral lines are arranged in an orderly fashion. He explained why the light is emitted by atomic gases and why those spectral lines are arranged in a particular order. Bohr induced the quantum idea with purely mechanical model of Rutherford and introduced the following three revolutionary postulates. By combining with the quantum theory with the mechanical model of Rutherford, he discussed three postulates. He gave three important revolutionary postulates. Those postulates are given like this. According to Bohr's model, electrons revolve around about nucleus only in certain special orbits called stationary orbits. If there is a nucleus at center, heavily mass nucleus, most of the positive charge, all total entire positive charges concentrated only at the center of nucleus, and electrons, negatively charged electrons, revolve around the nucleus at certain orbits only. Those orbits are called stationary orbits or allowed orbits. While moving in these particular permitted orbits, electrons don't emit or absorb radiation, electromagnetic radiation, even though they are in accelerated motion. Hence, the atom is stable. This particular postulate explained the stability of atom, not like in the Rutherford model. So this is the reason for electron to revolve around the stable orbit without losing its energy. And second one is that the allowed electron orbits are those for which the angular momentum is an integral multiple of h cross, where h is the Planck's constant, and h cross means it is h by 2 pi. So angular momentum of that particular electron which is moving in that permitted orbit must be equal to integral multiple of h cross. That means angular momentum MVR must be equal to nh cross. That means nh by 2 pi. We can write MVR equal to nh by 2 pi. Very, very important postulate given by Bohr. And the third postulate is states that the atom radiates energy only when the electron jumps from one of the upper allowed orbit with let us E2 to a lower allowed orbit, let us say E1. So there could be a chance of emission of radiation only when the atom jumps from higher orbit to lower orbit. So for example, atom is having nucleus at the center, and if there are two energy states, two orbits for particular atom, let us energies of these states are E1 and E2. If the electron from E2 upper orbit jumps from lower orbit to E1, then only energy is emitted. Otherwise, there is no emission of energy or absorption of energy if it is moving in the constant orbits. Energy is emitted only when the electron jumps from higher energy E2 to E1. So that means the change in energy E2 minus E1 must be equal to h nu. H into nu. Nu is the frequency of photon. Frequency of the photon. So that means when the electron jumps from higher to lower energy and lower orbit, that means it emits radiation or light with energy of that photon, particular photon must be equal to energy difference between the two orbits. E2. E2 is the energy of the second orbit and E1 is the energy of the first orbit. Then when electron is jumping from E2 to E1, the radiation emitted by that particular electron must be equal to the energy difference between the two orbits. Energy differences between the two orbits. So it is given by Bohr. But the frequency of emitted light is not determined by the motion of the electron, but is governed by the changes in its motion. Whenever the electron is moving in the constant orbits, it does not emit any radiation. It emits radiation only when it changes its orbit. These are the Bohr's postulates. These three postulates is able to successfully explain the reason for line spectrum, why the lines are in the orderly fashion, and what is the reason for the emission of radiation. So let us take a hydrogen atom. So Bohr atomic model for hydrogen is like this. For example, there is a positive charge here. In case of hydrogen, there is only one proton and one electron is revolving around the nucleus like this. So when electron is moving like this, let us consider charge of electron is minus E. Here charge of proton is plus E. So when the electron is moving, let us velocity of electron is V. V is the velocity of electron, and there exists Coulomb force between the positive charge and electron. And radius of this particular orbit be R be the radius of this particular orbit. Let us also assume that the electron is moving only in the circular orbit. And also assume that the mass of the atom positive charge is heavy compared to the mass of electron. These are the assumptions while doing calculations for hydrogen atom. Particularly this Bohr's theory of atomic model, Bohr's atomic model is able to successfully explain hydrogen atom and also single electron atoms like hydrogen, helium plus, lithium plus plus, beryllium 3 plus. That means single electron atoms. It could explain single electron models, atomic models. This particular theory, Bohr's atomic theory, could not explain the higher number electron atoms. This theory could explain only single electron model, atomic model. So if you try to find the radius of orbit, that first stationary orbit of hydrogen, let us say here, if the electron is moving in this particular orbit without losing radiation, that means if the electron is moving in the stable orbit, there is no change in the radius of this orbit, that means a stable orbit. So this must follow that the force of Coulomb force must be equal to the centripetal force of the electron. Then only this atom is said to be in that particular stable orbit. So that the centripetal force, here it is the centripetal force of the electron on the electron, that means mv square by r. If the electron is moving with velocity v and r is the radius of electron, so mv square by r is the centripetal force, must be equal to the Coulomb force, Coulomb attractive force, as there is positive charge at the center and negative charge at the orbit at a distance r, then the force of attraction between proton and electron must be equal to, as in the formula, as given by the formula, for force of attraction or repulsion is equal to 1 by 4 pi epsilon naught q1 q2 by r square. If there are two charges q1 and q2 at a distance r, then Coulomb force Fc equal to 1 by 4 pi epsilon naught q1 q2 by r square. So that now here there are two charges, one is plus e and another one is minus e. Then there could be attractive force, and this force must be equal to 1 by 4 pi epsilon naught q1 means plus e and another one is minus e by r square, and finally the magnitude, we are taking only magnitude of the attractive force 4 pi epsilon naught r square. So the centripetal force must be equal to, this one is the Coulomb force, must be equal to Coulomb force. So if you find the radius, if you calculate radius, that equal to epsilon naught h square pi m e square into n square. We already know the constant values like Planck's constant, h is the Planck's constant, h is equal to 6.625 into 10 power minus 31 joule second, and the constant epsilon naught, permittivity of free space, epsilon naught equal to 8.85 into 10 power minus 12 Newton meter Coulomb square per Newton meter square, and pi value, pi is also constant, and E, charge of electron, you know charge of electron equal to 1.6 into 10 power minus 19 coulombs. So after substituting all these constants, we will get as some constant r naught into n square. We can assume as all these are mass of the electron is also there, so it is also constant. Mass of electron equal to 9.1 into 10 power minus 31 kg, 34 kg, sorry. So we can consider these constants as r naught. So radius of orbit, different orbits depends on the n square of n integer, and where n is an integer 1 2 3 etc. So as number increases, radius also increases, and it is n square of the integer. Okay, so if we evaluate this constant r naught, we may obtain for first orbit, that is called Bohr orbit, Bohr first orbit, for n equal to 1, we can obtain that 0.53 angstrom. So Bohr's first orbit radius is equal to 0.53 angstrom. For hydrogen, that means for hydrogen, the first orbit radius is 0.53 angstrom. So it may change for different atom and a different number also. Second orbit radius increases, third orbit radius also. So radius of orbits increases based on the square of the integer 1 2 3 4, like that. So let us discuss the Bohr's model for single electron atoms like hydrogen, helium plus. Any atom, we can discuss any atom, but there must be only single electron. That means ionized atoms, any ionized atoms except hydrogen. In case of hydrogen, there would be only one proton and only one electron. So let us consider single electron atom. For example, the atomic number of atom is Z. So the nucleus charge would be plus Zu. And there is only one single electron which is moving around the nucleus at particular orbit. The charge of electron is as earlier minus E. Velocity of electron is V. Mass of electron is also M. Okay, so if the electron is moving inside this particular orbit, this must follow condition of centripetal force must be equal to Coulomb force, as explained earlier. Okay, so centripetal force must be equal to Coulomb attractive force between the electron and positive charge. So centripetal force of the electron mv squared by r must be equal to the Coulomb force. Here Z is the charge and minus E is the charge of electron, Z is the charge of nucleus. So let us take magnitude. Magnitude should be equal both sides. So here 1 by Coulomb force 1 by 4 pi epsilon naught. Q1 Q2 by r square means Z into E. We are taking positive only magnitude, that means Z squared by r square. So in order to calculate radius, let us simplify this equation. So here let us cancel RR. So mv square equal to Z square by 4 pi epsilon naught r. So let this equation number 1. Now here we are discussing different characteristics of atom, single electron atom. Let us derive radius, velocity, energy of single electron atom, energies of electron of single electron atom. So here mv square equal to Z square by 4 pi epsilon naught r. But according to Bohr's postulate, the angular momentum mvr must be equal to nh by 2 pi, according to the postulate of Bohr. Very important postulate. So from this equation we can calculate, we can find v equal to nh by 2 pi mr. So in order to evaluate the r radius of electron orbit, first orbit or any orbit, substitute this value of v in the equation 1. So we will get m into v square means, so m into v square means n square h square by 4 pi square m square r square. So n square h square by 4 pi square m square r square mv square equal to Z square by 4 pi epsilon naught r. So let us simplify this equation. Here we can cancel m and 4 pi, here 4 pi and 1 r, so that this equation becomes n square h square. Let us take this epsilon naught also this side, epsilon naught by pi m equal to Za square. by m, r also is there. So if we calculate for r, if you simplify r, for r equal to, if we take this r, so n is n square h square epsilon naught by pi z m e square. So this radius of electron changes particularly with value of n and value of z, and remaining values, all the values are all the parameters, Planck's constant, epsilon naught, pi, m, mass of the electron, e, charge of the electrons. So all these values are constant except only n and z changes. So radius of electron, let us say the equation number 4. So radius of electron or orbit, different orbits of atom, any atom, single electron atom, so must be equal to h square epsilon naught by pi m e square into n square by z, in terms of n square by z. So as the number n increases, radius increases, but as the atomic number z increases, atomic number z value increases, radius decreases. That means for the hydrogen atom particularly first orbit, we already find out that the orbit, first orbit of hydrogen atom is 0.53 angstrom. That is for hydrogen, means z equal to 1. If we consider higher atomic number, for example lithium plus or hydrogen plus, helium plus or lithium plus, for example helium plus, there is z value 2, atomic number is 2, so radius decreases, first orbit radius decreases, so it must be half of the hydrogen atom. First orbit of the helium must be half of the radius as that of the hydrogen atom, so it must be around 0.26 or 265 angstrom. So it changes with atomic number and integer n value. So let this equation also number 5. So now let us substitute this r value in the equation 3 to find out the velocity of electron in different orbits. Let us give the indication Rn to indicate radius of different orbits. First orbit R1, second orbit R2, R3, R4, like that. Okay, so you can say this equation, this value is also approximately, after substituting all these values, we already calculated all the constant values. So it is given as 0.53, the same parameters. So into n square by z angstrom. So if you want to find radius of any orbit for any single electron atom, we can say Rn equal to 0.53 into n square by z angstrom. By substituting the n value and z value, you can easily find out the radius of any orbit in any single electron atom. Let us say this equation number 6. Maybe you can use these equations later also. So let us substitute this r value in equation 3, V equal to NH by 2 pi m R. So R value can be substituted by equation 4. Then V equal to velocity of electron in different orbits. Let it be Vn equal to, let us see the NH by 2 pi mr. NH by 2 pi mr. R means here 2 pi m. M value we need to substitute from this equation. N square h square epsilon naught by pi z mu square. Pi z. So that means this value goes to up and this value comes into the denominator. Pi z mu square by pi z mu square by n square h square epsilon naught. N square h square epsilon naught. So after simplifying this equation, that means n, cancel n here, m, pi. So we are going to get h1 h also here, Ze square by 2 into n h epsilon naught. So this is the velocity in different orbits. So it is also given by E square by 2h epsilon naught into Z by n. So as the orbit value increases 1, 2, 3, etc., the velocity of electron decreases, and this particular value is also obtained as after substituting all these constant values, we are going to get around 2.18 into, after also substituting for hydrogen, particularly for Z equal to 1 and for first orbit 2.18 into 10 power 6 meter per second. It is less than the velocity of light. Okay, so this is the velocity of first orbit for hydrogen atom. If you want to find velocity of electron in different orbits for different single electron atoms, this could be considered as the formula. Let us equation number 7. So now let us find the energy values of electrons in different orbits for different single electron atoms. So let us say the electron is moving in the same stationary orbits. So if the electron is moving, that means it must have kinetic energy and it is also having potential energy. Then total energy, let us find energy values of electron. So energy in general is given by kinetic energy plus potential energy. So here kinetic energy as given by earlier slide, here in the equation 1 can be used for the finding kinetic energy of the electron. So mv square equal to Ze square by 4 pi epsilon naught r. So kinetic energy means half mv square. So half of this value, that means Ze square by 4 pi epsilon naught 8 pi epsilon naught r. So kinetic energy can be given as, let's see, Ze square by 8 pi epsilon naught r. So in order to find the potential energy can be determined by using the integration value, that means in order to bring the electron or remove the electron from orbit of radius r to outside, that means infinity, the work done, total work done in, that means F into F bar dot dr bar. So that means we can determine F Coulomb force will be existing between the electron in the orbit to the nucleus charge. So F bar Coulomb force is given by 1 by 4 pi epsilon naught Zd into minus E, means minus Zd square by r square into dr bar. It is from r to infinity. So after integrating this value expression, we are going to get minus Zd square by 4 pi epsilon naught r. So this is the potential energy. So we need to add this value here, that means minus Zd square by 4 pi epsilon naught r. So total energy of the electron in that particular orbit is equal to, here it is minus Zd square by 4 pi epsilon naught r. So after adding these two terms, we are getting minus Zd square by 8 pi epsilon naught r. After adding these two, kinetic energy and potential energy. So total energy in terms of radius is given by minus Zd square by 8 pi epsilon naught r. Let this equation number 8. So we can substitute the value of r obtained from the earlier equation here in equation 8. Substitute the value of r from equation, you can see earlier slide. R is given by n square h square epsilon naught by pi z mu square. Substitute this value in the equation of energy. So E is given by energy of different orbits, energy of electron in different orbits is equal to minus Zd square by 8 pi epsilon naught r, minus Zd square by 8 pi epsilon naught r. R means here n square h square epsilon naught by pi z mu square. So here we can do inverse of this equation, that means pi z mu square by n square h square epsilon naught, pi z mu square by n square h square epsilon naught. Let us check once. Pi z mu square by n square h square epsilon naught. So let us simplify here also. Z into z, z square, e square, e power 4. So minus, let us solve once again. Pi cancel. Any other terms? Epsilon naught into epsilon naught square. So finally we are going to get minus z square me power 4 me power 4 by 8 n square h square epsilon naught square. So this is the energy of electron in different orbits. So we can again write this expression as n equal to minus me power 4 by 8 h square epsilon naught square, as all these parameters are constant, and z square by n square. Here changing values are only n and z. So after substituting all these values also, we are going to get minus 13.6 into z square by n square electron volts in terms of electron volts. After maybe if you keep the constant values as it is, and after we may need to divide with 1.6 into 10 power minus 19 in order to get the value in electron volt. So finally we are going to get the energy of the electron in the nth orbit of the atom is given by minus 13.6 into z square by n square electron volt. So for hydrogen atom, particularly for first orbit, this value equal to minus 13.6 into 6 electron volt for hydrogen atom. That is also for first orbit. And again for second orbit, so minus 13.6 for second orbit, z is equal to 1. For hydrogen atom, z equal to 1 for hydrogen atom. In the case of hydrogen atom, the energy of first electron in the first orbit is given by minus 13.6 electron volt. The second orbit, z is also same for second orbit, so z 1 by 4 n square means 2, n equal to 2 for second orbit, so by 4, that means we are going to get minus 3.39 electron volt. And for the third orbit, E3 equal to minus 13.6 by 9 electron volt. That means around, if we calculate this, we are going to get 1.5 electron volt, 5 or 5.1 electron volt. For the fourth orbit, we are going to get minus 13.6 by 16 electron volts. That means 0.85 electron volts. So energy of every orbit for hydrogen or any other atom can be determined by this particular formula. Maybe En can be given as minus Zg square by 8 pi epsilon naught r. For we can find energies of different orbits, electrons in the different orbits. So in this way, Bohr explained the existence of line spectra. So in the case of atom, if there exists nucleus at the center and electrons, the outer orbits, first orbit, maybe second orbit or third orbit. So when hydrogen gas, particularly when the hydrogen gas is exposed to higher temperature, maybe the electrons are excited to higher orbits due to the absorption of energy in terms of radiation. So after exciting, they must come to the lower levels. While coming to the lower levels, the electron must emit the radiation. So for example, it is showing different lines at particular wavelengths, emission lines at particular wavelengths. That is due to the emission of these particular radiation. It emits only certain radiation of certain wavelength. And when electron is jumping from, for example, here n equal to 1, n equal to 2, n equal to 3, and n equal to 4, when electron is jumping from this particular n equal to 4 to n equal to 3 orbit, it must emit a particular a radiation of particular wavelength. And when electron is jumping from n equal to 4 to n equal to 2, it is also must emit a radiation of particular wavelength. So wavelengths are different when they are jumping from one orbit to the other different orbit. So in this way, we are observing these series in the visible region Balmer series at different wavelengths, H alpha, H beta, H gamma, and H delta lines. All these lines are due to the emission of light when the atom is jumping from higher orbit to the lower orbits, different lower orbits. And again, Lyman series in the IARE region, Paschen, this is particularly UV region. Lyman series lines are due to the emission of light in the UV region. And Paschen series, these lines are the IR. Here also bracket and fund, these are in the far IR region. So in this way, Bohr's atomic model successfully explained the emission of light due to the hydrogen atom. And this theory successfully explained the why the lines are forming at those particular orderly fashioned manner. So this is only due to the existence of stationary orbits, and while the atoms are moving in those stationary orbits, that particular electrons does not emit any radiation. The emission of radiation occurs only when electron is jumping from higher order orbit to the lower orbits. So these lines are observable only when electron is jumping from higher orbit to the lower orbits. So depending on the number of orbit, n equal to here n equal to 1, it is the ground state, very lowest energy level. That means it is in the energy of this ground state is minus 13.6. This negative symbol particularly indicates that the electron is bound to the nucleus, strongly bound to the nucleus. So if the electron is in the ground state, that means first orbit, if you want to remove that particular electron, we need energy more than 13.6 electron volt. For the electron in the second orbit, for n equal to 2, the energy of electron is minus 3.4 electron volt. All these energies are in the electron volt. So for the third orbit, this energy is 1.51. For fourth orbit, 0.85. For fifth orbit, 0.54. So as the number of orbit increases, the energy values also decreases in the negative sign. And it becomes 0 when n equal to infinity. That means the electron is going outside the atom. It is free of atomic bonding. When the electron is given sufficient energy, it crosses the atomic boundary. So in this way, the atomic wave number is given by this formula. This formula is maybe calculated from these energy values only. According to Bohr's formula, energies of the electrons in different orbits are given in this formula. So if you try to find energy of energy difference. That means when electron is jumping from one orbit to the another orbit, let us say 2 to 1 or 3 to 1, like this, we can find maybe n1 means 1 or 1 n2 means 2. We are obtaining 1 to 2 means n1 equal to 1, n2 2. So this particular line. So these values can be obtained. New bar, wave number new bar, maybe that is the difference. Maybe, for example, E2 minus E1 by, if you divide by HC, we can get new Lyman series, first line of the Lyman series. Nothing but this one. So we can easily convert into the wave number if you know the energy values of electron in different orbits. So easily we can find all the energies of all these lines. Energies are wave numbers, or wavelengths also easily can be calculated by using all these formulas. So all these lines are satisfied by Bohr's atomic model. So Bohr successfully able to explain the line spectrum of hydrogen. So Bohr's atomic model is successful model for particularly hydrogen atom or hydrogen like single electron atoms. But there are limitations. Limitations are given for Bohr model. So this model employed the quantum postulates and introduced quantum mechanics also, such as photon, existence of photon for the Rutherford mechanical model. But it explained with remarkable success of origin of line spectra in case of hydrogen atom particularly, which is a one electron atom. However, the theory could not give correct predictions for two electron atoms. It failed to explain the two electron atoms, model of two electron atoms. Bohr hypothesis established the relation of wavelengths to energy levels, but did not provide any general principles for predicting the energy levels of the particular atom. It could not explain the energy levels of particular atom. It did not explain why angular momentum is quantized. It is very important limitation, that how he considered that angular momentum is quantized. How the angular momentum is quantized. He could not explain why the angular momentum is quantized. That means why MVR must be equal to NH by 2 pi. There is no particular reason for the consideration of this postulate. He could not explain this postulate. And why atoms are make transition. He could not explain why the atom electron must take a transition from higher orbit to the lower orbits. But this particular theory, Bohr's theory, contributed immensely to the understanding of atomic structure. It is the very good moment for the investigations in order to find structure of atom. A more general understanding of atomic structure and energy levels is provided by quantum mechanics. So Bohr model played an important role in understanding atomic structure. So with this, I am going to conclude this lecture. Thank you all.
Like, share and subscribe. Hit the bell icon for more updates.